Let us discuss today the alternating current circuits and machines, LC circuits under week 12. So our learning objectives are, at the end of this module, you will be able to explain the differences and similarities between AC and DC current or AC and DC voltages. Analyze the AC circuits containing R or resistor, C for capacitor, and L for inductors. Explain the basic concept of generator and of motor, and explain why AC current is used for power transmission nowadays. So electricity can be divided into two types, the static electricity and current electricity. So under current electricity, we have the DC current and AC current, or DC for direct current, AC for alternating current. Okay, so we have DC versus AC sources. Now, in figure A, the source of electrical energy was a battery, which provides constant voltage. So kung makita nyo sa symbol ng DC, straight line, which means constant yung voltage. If battery provided a powered circuit contains resistor, the current will be independent of time. In circuit containing capacitor, inductor, or RC/RL circuits, the current can vary with time but always approaches constant value a long time after closing or opening a switch. So this kind of circuit is called DC circuit. In AC circuit, the battery is replaced. So same circuit, change lang yung battery into AC source. Ito yung symbol ng AC. To denote sinusoidal wave, no? So it is replaced by a device that produces electrical potential that varies with time. So this is called AC voltage source or AC source, where A is for alternating, C is for current. So again, symbol ng AC. The voltage at the output terminals of this device varies sinusoidally with frequency and Vmax, or called peak value. So the electrical energy used in your house is provided by an AC source. Okay, recall lang natin itong DC circuits. Okay. Sabihin natin DC circuits, ang source niya is DC voltages, no? Then ang mga produced na I is direct current. So this is a flow of electric current in only one direction. The source is constant. It's in the form of battery. If only resistor are in the circuit, current is independent of time. And if circuit contains C and R, the current can vary but always approaches constant value. Produced by sources like batteries, thermocouples, solar cells, commutator-type electric machines of the dynamo type. So yan ang DC. So we konting history. The famous inventor, Thomas Edison, originally proposed the use of DC electrical systems for houses and cities. So ito yung proposal ni Thomas Edison na DC ang gagamitin. So in the late 19th century, Nikola Tesla started to work with Thomas Edison, who had created the first DC power system, so to power the entire cities. But Tesla figured out the way to use AC power. May idea si Tesla na gagamitin yung AC power. Kay Edison, gusto niya DC. So even though Edison did not appreciate this idea, hindi in-appreciate ni Edison yung idea ni Nikola Tesla. Pero may rich industrialist, George Westinghouse, gave money to Tesla to build an AC motor. So yun ang simula na may AC motor para sa generation ng electricity, alternating current. So he used Tesla's idea to power up Chicago's World Fair in 1903. So after the war between DC and AC pretty much ended. So today, DC is still in use in places like solar panels and batteries na yung ginagamit pa rin natin. But using AC for powering cities is cheaper and safer. Kasi gusto ni Edison na to power houses and cities, gagamitin DC. But then, yung DC merong disadvantages pag malaki na yung supplyan, no? I mean yung output. So, advantage of AC, so generating an AC voltage is simpler than constructing and maintaining a large DC source. AC, electrical energy employ a generator based on magnetic induction. So, kung ang batteries, kailangan i-replace, ito, magnetic induction, no? Based on Faraday's law of induction, yung topic last time. So, yung Faraday's discovery ng magnetic induction, that was 1831. But the first generator based on this principle were constructed in 1832. So it did not take long to make practical use of Faraday's discovery. Useful ang discovery ni Faraday. So AC voltage produced frequency equal to the rotation frequency of the shaft. So in contrast, for a DC source such as battery, one would have to replace the battery to replenish the chemicals when being used, no? And for many practical applications, this battery would need to be quite large kung kailangan i-power sa mga large cities. So, ayun. So, yung principle of conservation of energy still applies. So, for an ideal generator, the amount of electrical energy dissipated in a attached circuit is equal to mechanical energy used to rotate the generator shaft. So, an electric generator is a device that produces electricity. Kaya tinatawag siyang generator of electricity, through electromagnetic induction. Electromagnetic induction is the process of generating electric current in magnetic field. So kung ma-recall niyo yung last meeting's discussion, there are ways na maka-generate na electricity by the presence of magnetic field. Generators may produce either alternating or direct, but they all change kinetic energy to electrical energy. So apply pa rin yung conservation of energy. So ito yung coil, no? And rotating shaft, magnetic field nasa center. So an AC circuits is like simple harmonic motion, no? The voltage variation of an AC circuit is reminiscent of a simple harmonic oscillator. Kung ma-recall niyo yung topic na pendulum, no? Oscillation. Okay. So there is also a close connection between circuits with capacitors and inductors and simple harmonic motion. Okay. Analysis of AC resistor circuits. How to calculate the current in an AC circuit. So if F is the frequency and Vmax is the amplitude of the AC voltage, the output voltage has the form of V is equal to Vmax sine of 2 pi ft. So this is called instantaneous potential difference. Kasi magbabago at any instant, no? So, recall natin yung Ohm's law. As time passes, the output voltage V of the AC source varies sinusoidally. That's why yung symbol is sine wave, no? So the current through the resistor is similarly time dependent. Inserting equation of Ohm's law, I is equal to V over R. There we have V max sine 2 pi Ft over R, where R is resistance. The current thus oscillates with time with the same frequency as the voltage. So the voltage amplitude V max is constant. So with note we have current amplitude is equal to I max sine of 2 pi Ft. So using Ohm's law, I max is equal to V max over R. And the root mean values, ito yung RMS values of current and voltage, are the peak current and voltage over the square root of 2. So the average of V squared is related to the voltage amplitude V max by the equation. So V squared or average of V is equal to 1/2 squared of V max or V maximum. So we now define quantity called root mean square voltage denoted by VRMS. Ito yung VRMS is equal to square root of V average. So familiarization, we have square root, average, square of the average value. Okay, so deriving the equation of VRMS, we have this one, and deriving the IRMS. So formula ng VRMS at saka IRMS. So we will not go into how to derive this, no? Anyway, may mga relationship na tayo before. So the root mean square values of the voltage and current are widely used to specify the properties of AC circuit. For example, in the US, the voltage in a household circuit has the value of 120 volts AC. So this voltage is actually the RMS value of the voltage across the terminals of the wall socket. So yung VRMS, yan ang nasa wall socket natin. Sa US, 120. Sa atin dito is 240. So power also varies with time. The instantaneous power oscillates between a maximum value of V max times I max and the minimum value of 0. So using the formula sa I max, sa I average and I and V max, no? Using I and V max. So substitute natin yun dito. And we have this one. Or the P average is VRMS times IRMS. So using again Ohm's law, when we have this IRMS is equal to VRMS over R, and to find power, IRMS or I squared of RMS value times resistance. So example, power and voltage in household circuit. So the standard AC voltage found in home in the US has frequency of 60 Hz. Pareho din yan sa atin. Sa Philippines, we have 60 Hz frequency. And is often referred to as 120 volt power, so which is the value of the RMS voltage. That is, VRMS is 120 volts. So what is the corresponding value of V max for the voltage at an electrical outlet? Okay, so using the relationship ng VRMS and Vmax, so since we are going to find for Vmax, then cross multiply natin ito. So VRMS times square root of 2 is our Vmax. Substitute lang natin dito. Then we have 170 volts. So the figure could represent a plot of an AC voltage with V max equal to 70. This is the value found in the example, no? So a DC voltage equal to RMS value of 120 would give the same average dissipated power in the resistor. Another example, as a circuit element, we can assume an incandescent lamp or light bulb. Yung incandescent light bulb, yung bulb na medyo orange o yellow yung color, no, ng ilaw. So function just like, so the relationships between the voltage, current, and power in the resistor apply also to light bulb. Household light bulbs are specified by their power rating. So kung kayo ay bibili ng bulb, tatanungin kayo ng nasa store, ano ang power rating? So kayo ang mag-decide kung ano ang power rating. So for example, one might be rated as 60 watt bulb. So this power rating refers to the average dissipated power P. So P average therefore is 60 watts. So when 60 watt bulb is used in a normal household, 120 volts, find the resistance of 60 watt light bulb. So simply, we'll use the formula of V average. P average is equal to V squared of RMS value over R. So to find R, transfer na natin itong P average dito sa baba and R. So R, therefore, so ganun lang. Exchange position, no? R therefore is squared of 120 volts divided by 60 watts. So the result is 240 ohms. I would like you to check the value of R using your scientific calculator. So the average power is important because it determines the amount of energy used by the light bulb over the long time. And that is how power company compute our bill. The instantaneous intensity of the light bulb depends on the instantaneous power dissipated in the filament. The power oscillates, so the intensity must also oscillate. Next, let us analyze the LC circuit. L is for inductor, C is for capacitor. So a LC circuit is a circuit with capacitor and an inductor, and let's assume there is no resistance. Kasi iba din yung circuit na merong resistance, LRC. Yun. Okay, so in this analysis, some excess charge is placed in the capacitor. Merong charge na capacitor. After t equal to 0, the charge moves from one capacitor's plate to the other, and the current passes through the inductor. So at t greater than 0, so there is I maximum flowing through the inductor. Eventually, the charge on each charge capacitor's plate fall to 0. The inductor again opposes the change in the current, so the induced EMF now acts to maintain the current at non-zero value. The current continues to transport charge from one capacitor's plate to the other, causing the capacitor's charge and voltage to reverse sign. Eventually, the charge on the capacitor returns to its original value. The voltage and current in the circuit oscillates between positive and negative values, and the circuit behaves as simple harmonic oscillator. So, yung flow of I clockwise, pagdating dito, would move pa-counterclockwise and clockwise and repeat again, no? So, the charge Q is equal to Q max cosine of 2 pi ft. For the current, I is equal to I max sine 2 pi ft. So, energy of an LC circuit. So, remember na yung circuit elements dito are capacitor and inductor, where capacitor stores energy in its electric field and depends on charge. While ang inductor naman stores energy in its magnetic field and depends on current. So, yung charge and current oscillate and the energy stored also oscillate. So, kung makita niyo itong blue graph is the potential energy of the capacitor. We also have the potential energy of the inductor. So potential energy total is potential energy of the capacitor and potential energy of the inductor. So to compute for that potential energy ng capacitor, we have this one, and sa inductor ito. Next is energy calculations. So the energy oscillates back and forth between capacitor and its electric field, and the inductor and its magnetic field. So the total energy must remain constant. The maximum energy of the capacitor must equal the maximum energy of the inductor. So equal, walang nawala. The total, from the energy considerations, the maximum value of current can be calculated by this formula. So I max is equal to 1 over square root of LC times Q maximum. So this shows how the amplitude of the current and charge oscillations in the LC circuits are related. So RL, yung kanina LC, RL ngayon. R stands for resistor, L for inductor. So this is a circuit having resistor and inductor. So no capacitor. So when the input frequency is very low, the reactance of the inductor is small. So what does this mean? So the inductor acts as a wire, and voltage drop also with 0. So ito yun. Itong inductor na to ay naging wire na lang. No? So voltage drop in that situation is 0. At high frequencies, the inductor acts as an open circuit. High frequencies act as open circuit, so meaning walang electric current, and the output voltage is equal to the input voltage. So whatever be the value of V in, yan din yung sa V out. So these circuits act as high pass filter. So when we say high pass filter, that is an electronic filter that passes signals with a frequency higher than a certain cutoff frequency and decreases signals with frequencies lower than the cutoff frequency. Next, when the input frequency is very low, that is the reactance of the capacitor is large, the current is very small. Capacitor acts as an open circuit, and the output voltage is equal to the input voltage. So ito yung situation kanina na at high frequency ng inductor. Dito, high frequency ng capacitor. So high frequency ng inductor is like high frequency ng capacitor. So high frequency, the capacitor acts as a short circuit. So inductor acts as a wire. Output voltage is 0. And the circuit acts as low pass filter. So when we say low pass filter, is a filter that passes signals with a frequency lower than a selected cutoff frequency and decreases signals with frequencies higher than cutoff frequencies. Next is the concept of transformers. So transformer are devices that can increase or decrease the amplitude of an applied AC voltage. Kasi meron tayong tinatawag na step-up transformer. That's to increase. Step-down transformer is to decrease. No? And then we have, kung ma-recall ninyo yun sa previous topic about mutual induction, we have two coils, no? So primary and secondary. So yung primary induces electric current to the second coil, so secondary coil. So transformers do what their name implies. They transform voltages from one value to another. The term voltage is used rather than EMF. Kasi pag sabihin natin EMF, walang internal resistance. But then when we say voltage or terminal voltage, we have to consider internal resistances. So a transformer is consists of two solenoid coils with the loops arranged so that all or most of the magnetic field lines and flux generated by one coil pass through the other coil. One coil pass through the other coil. So the wires are covered with non-conducting layer so that current cannot flow directly from one coil. An AC current in one coil will induce an AC voltage across other coil to the other to other coil. An AC voltage source is typically attached to one of the coil called input coil. The other one is output coil. So we have for input we have usually natawag na primary and secondary. So equations ng transformer we have, or recall natin yung Faraday's law that instead of Vn we have EMF, no? Induced EMF is equal to change in flux over time. So specifically we have V voltage in is equal to flux in over change in time. So total voltage naman we have V out is flux out over change in time. So when we consider the N, or kung ma-recall pa niyo yung N is the number of turns ng coil, no? Now, how many turns, no? So flux out is equal to N out, where N is again is number of turns, over N in times flux in, number of turns. Recall. Okay. So in terms of voltages, so how many turns? Ano ang output input voltages? And in terms of current, how many turns? Ano ang expected I in and out? Okay. So the ratio of the turns can be greater than or less than 1. Therefore, the input voltage can be transformed to a different value. Transformer cannot change DC voltages since they are based on Faraday's law. Most practical transformers have central regions filled with magnetic materials, and this produces a large flux, resulting in a larger voltage to both the input and output coils. So ratio delta, we have ratio of V out over V in is not affected by the presence of magnetic material. So we have this input coil and output coil. So transformers are used in the transmission of electric power over long distances. Many household appliances use transformers to convert the AC voltage at the wall socket to smaller voltages needed in many devices. There are two steps in doing this, in converting. First, needed to convert 120 volts to 9 volts. I-reduce yung voltage, and that's from AC to DC. So transformer voltage, the output voltage ng transformer can be made much larger by simply arranging the number of coils and based on the conservation of energy. So with that, we have power in is equal to power out para sa ideal transformer. But then sa real transformer, the output power is always less than the input power due to power loss. So example, we have portable X-ray unit has a step-up transformer. Step up, meaning ipa-taas yung voltage. So 120 volt input transform to 100 kilovolt output. Kailangan yan sa X-ray tube. So the primary has 50 loops and the current of 10 amperes. So what is the number of loops in the secondary? So kung gusto niyo Plot niyo yung mga given values dito sa figure. So, input is 120 volts. Output should be 100 kilovolts. 3, 4. 100 kilovolts. That's 100,000 kilovolts. And then we have primary, 50 loops. 50 loops. And 10 amperes. Hi. So, sa letter A, find the number of loops. So, find the number of loops in this secondary or sa output coil. Find the current output of the secondary and find I at the secondary. Okay? So, recall lang natin yung formula. Ito yung formula for V and formula ng I. Okay. Since N out ang hinahanap, then manipulate niyo, simplify lang niyo ang formula. That N out is equal to V out over V in, and then multiplied by N in. Next thing is to substitute all values, and then use your calculator. Take note na makancel itong volts, giving us unit na number of loops. So, by the way, this is 50. So, from 50 loops, parami yan hanggang sa 41,700 loops para magkaroon ng higher voltage. From 120 nakasaksak sa socket, ang ma-produce is 100,000 volts. This is to operate an X-ray. Yung X-ray kailangan ng high voltage. Next is to find I. So to find I out man. So pwede ito, diretso na kayo plug in sa given. So where our N out is the answer in letter A. So kung mali kayo doon sa computation ng in out, so it would follow na magkamali rin kayo sa B. So be careful in your computation. So next is that we have to discuss the basic concept of motors. So a motor is an AC voltage source that can use or that can power a motor using AC voltage para mag-function. And then AC source is connected to a coil wound around a horseshoe magnet. Around a horseshoe magnet. This is our horseshoe magnet. Bended bar magnet. So the input coil induces a magnetic field that circulates through horseshoe magnet. Input coil ito. Okay, so an electric motor is an electrical machine that converts electrical energy to mechanical. So yung generator kanina, mechanical, it converts energy from mechanical to electrical energy. So yan ang kaibahan between motors and generators. So most electric motors operate through the interaction between motor's magnetic field and electric current in a wire winding to generate force in the form of torque applied the motor shaft. Torque. Kung makita nyo ito, torque is equal to force multiplied by perpendicular distance sa axis of rotation. So tendency nito is to move clockwise at the same time. Okay, so repeat yung ikot nito. So moving the coil in the presence of magnetic field, ang concept ng motor. So a second coil is mounted between the poles of a horseshoe magnet and attached with the rotating shaft. The forces acting on the second coil produce a torque on the coil, and this causes the shaft to rotate. So as the AC current in the input coil changes direction, so as you can see, meron siyang up, then dito sa pababa. So ibig sabihin there is change in direction of the I. So the torque continues to produce rotation that is usually in the same direction. The oscillations of the AC current and field make the shaft rotate. Advantages of AC. So why is it that we use AC? So biggest advantage is in the system that contribute electric power across long distances. So AC is used especially in the power distribution system wherein my power delivered through distances. Na? The power generated at the power plant must be distributed to distance places, and the power plant acts as AC generator. Okay, so this is the um, power distribution system from power plant to houses. So there is power dissipated in the power lines. That is equal to P is equal to I squared. I RMS squared times R of line or resistance ng conductors. Next, the power company wants to minimize these power losses. So yung power company, ipababa nila yung IRMS. Ang voltage naman yung i-increase in order to decrease the current. So a transformer is used to drop high voltages in the power lines to lower voltages at the house. So dito yung AC generator, step-up transformer, ipa-increase yung voltage. Tapos i-travel sa mga high voltage transmission lines. And then i-step down para sa substation. And then travel yan. Meron transformer para ipababa doon sa houses and consumers. So that's all for today.